different things we have to help us, because there's a lot of neat stuff here. We're going to be talking basically about three things: drill presses, lathes, and hand drills. And the accessories that are available to you, the types of drill bits are available to you, and the things that you need to know. So let's start with this. This is a great machine for drilling straight holes 90 degrees. When I say 90 degrees, that's being in the, that's not going to be a perfect 90. And what happens that? Well, it means if you're going to try to drill a pin blank and you go wild and crazy and try to do a long one, dead center here is probably going to be over one of the edges here. So if you want something actually dead center down a long piece of wood, we go to the lathe, because this goes down right down the dead center of the shaft. But this is great for normal everyday stuff that you're going to use for making. The hand drill, we probably use that more than everything else, and that can give us all kinds of issues, especially with putting screws in, if we don't go dead 90 to it. If we introduce different angles, then we can run foul of stuff later on. So we're going to do with this stuff and do it fairly easy. So the drill bits we want to use, we've got a lot of different choices of bits, but basically for woodworking we're using two. We're using Forstner bits, and we're using brad points. Now the brad points and the Forstners are common in that they have this little point sticking out. Okay, the point's important because that keeps the drill bit from wandering as the teeth engage the wood. So these are nice to have. We also have this is a 7mm bit. Okay, this is a 7mm bit. They don't look the same. Okay, this is designed for drilling 7mm holes in all kinds of wood products. This is designed to drill a 7mm hole in a pen blank, because they think you're going to be wild and crazy and do silly things like go through the whole blank. Okay, but you see, even this long one doesn't go through the whole blank. So this tells you right away they expect you to chop this up. Thing I don't like about this one is that leaving the play with, you're going to get vibrations, you're going to get stuff, and it's not going to be as accurate. So what I do when I'm drilling 7mm holes, I start with this. And once I get it about halfway in, I take it out, and then this goes in halfway, and I do the rest of the way. But I'll pass this around. Look at the difference in flutes. This is designed to get debris out. This is designed to get a lot of debris out really quickly. But the flute size determines how much debris is coming through. Why is that important? Because if the debris gets stuck and it's pressed up against the side, that's when you see smoke coming out of the hole, because you are really, really causing friction to heat the wood up. And if it's going to be a big hole, you actually crack the wood. It can heat up so much. Bits that I use are, where'd this little thing go? Here it is. These are drill centering bits. These are starter bits. Tiny little things, okay? That's a 60-degree cone right there. So you put this in your chuck, and all it's meant is just to go just a little bit in. And it works with two things. It works with the point on these, or if you've got a 60-degree live center, it works the point on the 60-degree. So that one, you just make a little thing like that, and that live center is going to line dead perfect with that. So this really gets you into the hyper accurate range. And if you want to do neat things like Celtic knots, you need that. You need that ability to drill a long hole in this straight dead center from one end of the blank to the other. Otherwise, this is not going to come out right. The knots are going to be open and closed. So this is what we're looking for when we're looking at this stuff. So let us begin. And we'll start with the lathe right now. We're going to use just a simple scusa. We use a 7 mil. What I like about the lathe is the wood turns and not the drill bit. So this, it's very easy for us to put tape, make marks on the drill bit as far as depth goes, depth of cut. Some lathes also have on this live center arm right here, the ability, it's measured. You can actually use the measuring thing here. So what we'll normally do is just have it touching, just the tip touching, turn it on. RPM. For a bit like this, 1500, 2000, it's not a problem. Forstner bit, we don't want it over 800 RPM. The nice part about lathes like this is I can just dial it down as slow as fast as I want. If you're going to use a Forstner bit, and we're going to use one here in just a minute, what we'll normally do is just lock this down so it can't slide and just turn the crank. Let it clear, turn the crank. What we can also do is loosen this up and just press it forward.
The vibration that you're hearing, is that the base of the lifestyle?
Yeah. You're hearing the wood vibrate because it's flexing. You're hearing all kinds of neat stuff. But what we've got here is this neat hole. Okay. Remember, this is grabbing it so that this is right down a long axis here. But if we look on this side, it's off. Okay, why is it off? It's off because this was sitting in the chuck just like this. So how do we make sure that this is flat to the chuck? If we'll notice, a lot of these chucks have the ability that you can slide here, and if the hole's small enough, it'll stop. If the hole's too big like this one is, well, how do we do that? How do we make sure that this is lined up between centers? And what we do in that is we're going to take a smaller piece. Here it is. What we do is we take one of those little jigs that you make lines, center mark, and then you're going to make a little hole here, which is where this comes in. This is really great because I'll put this in a jig. I'll do on both sides. Line it up, put a little dot here, okay? Then we can take this and we can actually clamp it in the between centers. And when we clamp it in between centers, we can actually turn this and we can work on this face here to get it nice and flush. But once we know we've got it there, the hole goes right through. But don't think you can just put it in here and the jaws are going to line it up. Now, there are specific pin jaws that I use this to get this little bit right here. But there's pin jaws that actually are this long, and those are designed just to come down on two sides, and that will straighten it out. So if you have pin jaws, you really don't need to do the little X's and things like that. And they call them pin. These are called pin, P-I-N. And there's only two pin jaws. But that will hold it tap dead center. The problem is they only work on something no more than an inch thick.
I'm having a little trouble with my lathe. I can record it.
Mm-hmm.
Do you have to round before you round the end off?
Mm-hmm.
Let's say you do the 2 centers, because you get 2
Mm-hmm.
centers and you round that end off.
Mm-hmm.
That should suffice so that you get it in the jaws and you tighten it down.
Mhm.
Is it not?
Right. The reason is those pin jaws they're cut in V's like this. So if you put around something in those V's, it's going to self-center. Here's more V's here. So two pin jaws coming together will hold that round thing tap dead center.
Even if I use one like that, if I use those jaws?
No, these are not. I'm talking about PEN jaws, the long ones. Okay, but they'll hold this tab dead center.
Okay.
So this could be off this way, this could be off this way. They won't care. Pin jaws, or you want some. I always like to mark the centers, turn them into a cylinder, and then what I'll do is I've got a mark here where the live center was. I've got a mark here where the drive spur was. When I put them in the clamp, I'll put the drill, go halfway down, flip it over, put the drill, go halfway down. Just to show you. Okay. We got you covered. This is advanced drilling 101. So now we want to do the same thing. We want to be in the center. Okay. So how we're going to do that? Oh, another thing I want to show you too. Two pin blanks. The same size? But they're not square either. There's no uniformity. So what I like to do is, because of this, put them between centers and then round them over, then they fit these things perfect. I drill my holes, life is good. Another thing you can do is, if you pretend this end is flat, if I take it into a chop saw that's set right and I cut that, then theoretically this is flat and this is at 90 degrees to it. And if I get a little bigger sample, then it'll hit the face of the jaws, face of the thing. That's as far as it'll go. Now if I clamp it, it's going to be straight. That makes sense to you. This is
Well, yeah, and you squared up the other end.
Yeah.
Square.
So this is square.
Right.
I got my reference.
Right.
So then I put it in here. Boom. Now it's going to be flat. Now if this is crooked, when I put it in there and do it flat, it's going to give me this. And even if I close this up, it might not grab it in such a way. You can see that this is only grabbing at these little points. That pin vise is a big V, and it grabs at that whole V. It's only, the pin jaws are only designed for one thing and one thing, drilling holes in blanks, period. You don't turn with them.
3 or 4. Is that a 3?
4. It's a woodchuck, it's 4.
Okay.
Now, all woodchucks are 4, metals are 3.
Okay.
Don't know why, just the way it is. So, this is a good way to drill though. And we can drill big holes, we can drill little holes. For example, we want to make a bottle stop. It's Christmas time, we're going to visit friends, we're going to bring bottles of wine. Lumber time, I'll bring bottle stoppers too and give them. So what we need, now this one is going to be flat. So we're going to hold it here, and these jaws are all we'll need. These will hold it nice and flush. And we're going to drill. Now how this is going to work, I make these about 2 inches long, okay? This is longer than 2 inches. That's good because I want something to grab. I'm going to go in about 1 inch, drill a hole about 1 inch with a 1 1/8 inch Forstner. That usually will fit most wine bottle. And then I'm going to go in a half inch Forstner. And that's for the little dowel that I'm going to put the silicone thing on that's going to seal the bottle, okay? So 2 holes, a big one and a little one. And then the neat part about that is then I can flip this over and bring those pin jaws inside and expand them. I can turn it on the outside, do everything I want. Or if I didn't want to expand because I'm worried about it cracking, I glue the 1/2-inch dowel in there, and then I take a set of jaws and they will come in and they will hold that, and I would just turn. But I have to let the glue set for that one. This is what we're going to do. So that's there. Yep, okay. This is 1 1/8. 1 1/4. That'll work. Now, I can do this 2 ways. I can measure from here to here for 1 inch and make a mark, or I could set arm here that you can't see, but you can come up here when we're done. Yeah, calibrations. So we'll come in here. Maybe. Really? Come on. There we go. Okay. Yep. But actually, it's going to be close enough for what we want, because even though the hole is going to be over,
Yeah.
when I turn it on the outside, I'll show you. Whoops. So. Maximum RPM is 800. Okay. So we're going to crank this up just a little. Okay. That jumping right there now is this bit bouncing up and down. Okay. Well, it's not touching the center of that wood. So what we want to do, yeah, it looks like it's the, yeah, I feel the vibrations. It's about 1 inch down. We'll keep it that there. Now this is going to be warm, so be careful when you take it out. Now the last hole we want to drill, this is the 1/2 inch hole. And that is, nope. So this is what a 1/2 inch dowel is going to go into. And we want to not touch this at all, because even if we've got this offset, the hole is going straight in. The second hole is going to go straight in. When we grab it by the inside and turn the outside down, the outside is going to go like that as we take the extra wood off of it. and that measurement was off. So we actually didn't go down far enough. But that's okay, because I'll just put this in here and we'll just show you the idea. Normally, this didn't go in an inch. I think this is moving back a little. But this will give you the idea. Okay. Now to do this for real, I would re-drill it for what we're doing. This shows it better. So here's what we've got. We've got this hole. It's supposed to be an inch down. Didn't quite make it, but this is supposed to be a ½ inch. We're going to go a ½ inch dowel in here that's going to poke out a little bit, and the stopper bottle is going to go right on top of that. Now here we see that we've got a little thin here, little thick here, and these two are about the same. When we put this in here now and grab, either expand this out to grab it, or put something here and glue it and then grab that, that is going to line up with the inside and not the outside. So when I turn the outside now, it'll bring it down. So when I first start turning this, the last thing the cutter is going to touch is this side right here. So it'll cut everything else, but when it gets down to that thinnest part that I'm watching, I stop cutting. So that means that the whole thing all the way around is going to be this thick. And that's fine for a bottle stopper. Okay? And then what I do normally, if I go in an inch, another ½ inch, I go to 2, make a line, turn a nice dome. You always want a dome because people do this with bottle stoppers.
And you gotta be careful with clearance in your refrigerator.
Right. And this I like because this is only 1 inch above the top of the wine bottle. I call these refrigerator bottle stoppers.
Okay.
So because you went an inch and you've got only 2 inches max, only inches above, so only that much is above the wine bottle, so it goes into the refrigerator.
And what do you have? Wait a minute. Does the bottle go like over the bottle?
Goes over the bottle.
And then do you do a stainless steel stopper, or do you just do?
I use stainless steel with silicone. Or if you're using a dowel, you're just using a silicone stopper. You can do 2 ways. You can drill, if you wanted a cork, you drill a 3/8 inch hole and put a 3/8 inch dowel. If you wanted a silicone stopper, you do a ½ inch hole, a ½ inch dowel. If you wanted to screw in one of those, and I've done those stainless steel ones.
Oh, the stainless steel goes actually in there, so the same thing, the bottom goes right over.
Goes right over top of it.
Oh, that's pretty cool.
So it really works well. But this involves drilling these 2 holes. And the best way to drill these 2 holes so everything lines up is here. Because if I try to do it here and change stuff and move it around, I won't necessarily put it tap dead center anymore. Okay?
Can I ask another question?
Mm-hmm.
If you use the stainless steel bottle stopper, do you do that second hole, or do you make it big enough for the thing to screw in?
I make it a little bit smaller, then I take a tap and I either 1/4 or a 3/16 and I tap it. And then I decide if I want to take if I don't want to make it interchangeable, I put a little epoxy on the threads and put it in there and it's a done deal. If I want it so you can change it, like when I do the golf balls,
Yeah.
I don't epoxy those, so they screw right on the top and they just stay there.
Right.
So if you want to change if that's not their brand and they want another brand, screw it off, put the other golf ball in there.
Golf balls are easy. All you gotta do is drill a hole, don't you?
It's really easy. You're going to grab them in those. You're going to get a 3/4 inch Forstner bit.
Yeah.
Okay, and you're going to drill it till the edge of the Forstner bit meets the edge of the golf ball. Stop.
Yeah.
And now you have a flat 3/4 inch hole.
Right.
Flat spot with a little dimple. Now you take whatever you're going to use. If it's the fat screws, you're using a 3/8 and drill the hole. And if you want to thread it and unthread it, you make the hole smaller and then tap it.
Right.
Drill a 1/4 inch hole, drill a hole, slap full of epoxy, stick it on there, you're done.
Yeah, that's great.
And you can do that with most any tops. But when I drill those holes, I'm drilling them here because this is going to give me the best accuracy for doing stuff like that. Now, coming over here, we're going to drill a hole with this. And again, let's use, we'll use a Forstner bit. The lathe was really easy to set the speeds. This isn't, because this has got belts. Okay. Regardless of what they give you to hold this on there, buy a 1-inch rare earth magnet, stick it on the side, and do that. All these drill presses have something like this. Even the ones that are automatic usually have some type of clutch and belt combination. The only ones I know don't are the DVRs. That's the motor itself that does the slowing. Everything else, usually the motor turns at a belt to do that. That being said, that's why in the ones that are automatic, if it's got a clutch system, it tells you the only time you can change speeds is when the drill press is running, because otherwise the belt is going to come off. This one here is set. If you look, there's a picture up here. Tells you the speeds based on where these belts are. Right now, this is set at 800 RPM. Okay. If you're using little tiny drills, you crank it up to 3,000. But for what we're going to do with a Forstner bit, 800 is what we want. And so one of the things I like to make is cigar holders for my golf cart. And what I do is I'll take a block of wood like this, and I'm going to drill 2 holes. I'm going to drill a big one right here that the magnet's going to go into. That's going to hold it to the golf cart. And I'm going to draw a big one right here, not quite as big as this, down this depth that you put the cigar in. So you're smoking your cigar, you want to take a shot, you put it in here, you walk up, take a shot, come back here, take it out, off you go. Easy to do, but we're going to use this, and normally with this, I set the depth 1/8 of an inch down for the holder. Most drill presses come with this. Okay. What this is a depth stop. So depending on where the table is in the overall scheme of things, this will get to this depth and stop. So we also know that vibration of this thing is going to make that move. So that's why the second one is here. So you just screw this down until it gets the first one and it locks it in. Now, the 2 times I really hurt myself in the shop because I didn't clamp it, I was holding it. One, I was drilling out a putter head to put a bigger shaft in, and the metal caught, and the head swung around and went whack, and my fingers just went, ah. Another time was a block of wood. I was drilling holes to hollow out the block, and about the third, it caught and came around, and when it hit me here, I still got the big V scar. Just whack, and blood everywhere. You come in the house dripping, and drip, hands full. Your wife's going, don't drip it on the floor, and what the hell happened? So what we're going to do, and what I like to do now, is get some type of mechanism. And this is really good because this, on this table, slides back and forth all the way around. It lets us do. Another thing I've done on my drill press is I put a drill press table on here that's got, I can use fences, I can use clamps, I can really multitask with it, and it does a really, really good job. But for this, we have to be careful that we don't put this right into the drill. So what we're going to do here is come down, move this here, There we go. That holds it there. Make sure we're not hitting. We are hitting that there. So there we go. We're good. So this will hold it in place for us. The nice part about this, if you're using a metallic cut to hold the magnet in, there's my starter hole for where the hole I'm going to drill so the screw will go in there and not split the wood. So this not only does a great job putting the hole there that the magnet's going to go into, but the cup that holds the magnet, I'm going to hold in place with a screw. So then I would just turn around, drill this out more, put it in a lathe, turn it around, hold it. It's just a fun, neat, easy. But they both do an excellent job. It's a little easier, I think, to drill this here when you got a nice big flat surface and you're mowing up and down versus here, because here you've got this you're holding, this is going at a different speed. It's just what you're most comfortable with. This will give me more cuts if I'm doing something like this. But if I'm not doing something like this, this is great. Plus with this, these decks will have a release here that you can turn this to a certain degree. So if your hole needs to come in at an angle, so you've got something and you want the hole this way, so you're holding something in an angle, you can do that with this. Why would you drill a hole at an angle? Well, if you've ever done a chair, most chair legs don't go straight up and down, they splay. So this is where you'd put, and I do this when I've got a flat bottom on the seat that I can, you don't, you can then drill your holes. Do it when it's flat, then shape around the hole. This does a very good job with that. Again, the biggest thing is the type of drill bits we're going to use, and mainly for us, it's either going to be Forstner or it's going to be a brad point. Takes us to this next one. We've got some wood we want to drill holes in, and we want to make this as accurate as possible. If the holes have to be, absolutely have to be totally in the same place, then what we do is we just stack the wood, clamp it down, and just blow through them all, okay? And that will give us holes exactly in the same place on each piece of the wood. The other reason we would actually use a second piece of wood is, and you see this a lot with Forstner. Oh, this is too big for a hole. Okay. Normally, if I've got a big opening right here, and I take the Forstner, or this little hole right here, this is where the drill bit's supposed to go through. If you've got a Forstner bit, you got a little hole, it won't go through. That tells you got to do something with Forstners. And what you have to do is you have to put a backer board. A backer board does two things. It keeps it from going all the way through, and it keeps you from getting blowout. Because I guarantee you, if you don't have a backer board on a Forstner bit, it's going to blow out. So, we're going to come here. Lock this down. And what we'll do is we'll now, what I want you to do this is listen, because there's two ways we're going to know we went through the first board. One is you can feel in the handle a release of tension. It just a little thing. The second, we're going to hear it go through. And so you'll hear it when it makes that transition. Here. The pitch changed. That's how thin it was when the pitch changes. It's right there. So all we're doing is that little change of pitch. It's a very subtle change. Now, I did this on purpose because I wanted to show you this. This is what you're going to get with the tear out if you don't have a backer board.
You had that.
Yeah, but I stopped it before I went through. Now this one I'm going to go all the way through.
The difference is it's not stopping, it's going all the way through.
Mm-hmm. That's why these are called demos. Same thing. There we go. So you don't have to go in very far, but when you use the backer, just plan to go deep enough just to make a little mark on the other side. So where does this come into play? Humidors. And I like to make vertical slits in humidors, so the cigars, you know, you can divide them into compartments. And I'll put these holes all over that Spanish cedar, but I don't want tear out. So what I'll do is I'll get my little backer piece and I just make the holes and then make that the divider in there. It does a great job. Time you may use a Forstner bit, anytime, if it's going to be a through hole, you will get tear out, and it can be significant tear out. So if it's going to be a thing that somebody's going to see, make sure you've got a backer board there. Okay.
Red point do the same thing.
Yep. Yep. We get a honking Brad point bit in here. Nope. Don't do that. Don't do that. Well, let's make this one. Make sure it's lined up over the hole. It is. There's your tear out. And we'll put the hole on the side. So the backer board is very important, whether it's Forstner bits, whether it's Brad point bit. If you do a through hole, you're always going to get tear out unless you have a backer board. If it's in the middle of something that you're never going to see that edge, who cares? But if it's not, if it's something that people are going to see, then you always want to drill those holes with the backer board.
What can you do to eliminate that?
What you do is you always have, when you use sandpaper, you always want to have a backer on it. Just a little sandpaper, give you a nice clean edge. As far as the stuff in the middle, don't worry about it, because the dowel or whatever it is you're going to put in there is going to blow it away. But this gives it a nice crisp edge. Sometimes you can even get in here a little bit and do some damage control with it like this. But normally if you get a really case of bad tear out, there's not a whole lot you can do to hide it.
I run into that when I was in the Craig jig quite often.
Oh yeah. Now this is a really rough grit. This is a sandpaper. But you can look at now and you can see I've worked this a little bit. There's not a whole, that's pretty deep. There's not a lot I can do there. But that doesn't look as bad as it did before with a little sandpaper. So, works really good. Straight holes. We can vary the speed. We have a big deck to put stuff on. We can clamp the stuff down for safety. We're going to use backer boards. Forstner bits work great. Point bits work great. Depending on the size of the bit, you can change the speed up here. It's very easy to do. Basically, in this particular one, you've got a screw here, a screw here. You loosen these. Once those are loose, you take this handle and you pull it forward, and the whole motor assembly comes in. That loose. Move the belts. When you get the belts the way you want them, push this all the way back, moves the motor away, tighten this screw down, you're good. Changing belts, moving belts around is really not difficult on this. The irritating part is going from one to the other and back again. Takes us to what most everybody uses. Oh, we can also drill round stock in that as long as we have a V-groove block. It doesn't matter what the block is, but with the V-groove to hold this in place, then we use a clamp to clamp it. We can draw holes long. It just, you need a clamp and you need a V-block to do it. You can also do this if you have a clamp and a V-block. You can do it on a bench. And I just grabbed these two because these supposed to have V-blocks cut in them. They just happen to be guides. And what do I mean by guides? In this case, is we want to drill a 3/8 inch hole in this dowel. And we've got this marked where we want our 3/8 inch hole. So with this clamp in place, and the V-block, we want, and this is going to let us do a nice vertical hole, okay? I would personally like the bottom V-block to be a little bit bigger than this, so this is just more like showing you what it looks like. Also, you want to make sure that your clamp is straight up and down. The clamp like this tells me that this top block is cocked a little bit. But this gives you the idea. You need to have something that sits in, it's got to be a V, a 90-degree V, and you need to clamp it down. So that being the case, what are these good for? Well, the problem we said we had with drills is, let's do a quarter. These hand drills have a couple controls that are common. One is this little thing, these numbers. This is torque. This is a release point. And if you're going to drill a hole, it needs to be on the drill picture. If you're going to put screws in, you use this clutch so that when the torque gets to a certain point, the drill lets go so it doesn't twist the head off the screw, which I've done a lot of Craig screws. So this is important. Normally, all drills or most drills, the good drills, are variable speed. And you look at this and you go, I don't see a variable speed control. Yeah, you do. It's called the trigger. Low speed, a little higher, a little higher. Plus, your drill should also give you an indication of, I like a work light, and I like to tell me how full the batteries are. Because I don't be in the middle of a project and the batteries runs out. This particular drill, this is the work light, comes on. So it lights up right here. These little lights are the battery. 3 lights is full charge. 2 lights is 2/3 of a charge. 1 light is you're going to lose your battery here pretty soon. So this is a good thing. Usually it comes with 2 speeds. And this one too is a little faster, but it's still a variable speed. So we're going to drill a hole with this. So we're going to have blocks of wood here. We always want to make sure that we don't drill into the tabletop if we got a tabletop, so we can clamp it. We can have holes in the tabletop. We can play like the drill press and go through the holes. Mm-hmm. It's a big boy. Mm-hmm. Now, with this, I can drill a hole this way. I can drill a hole this way. I can drill a hole this way. But there's times when I need to make sure that hole's straight up and down. There's where these drill blocks come in. So if I need to make a hole straight up and down, again, the drill blocks I like to clamp, but this is going to make so that you hold this vertically, because you can't do it anything else but vertical. And so now, these 2 holes are lined right up together, this one and this one. So I can put a fastener between the 2, and I can do all kinds of stuff. But I know these holes are straight. And a lot of times, if you're doing multiple things to attach stuff to, if you're going to put a screw in here and the screw thing is off and you've made all your measurements, and you take that misaligned screw and put it in here, instead of having an edge that looks like that, it's going to look like that when the screw pulls the pieces of wood apart. So holding 2 pieces of wood together in an exact place, you need a hole that's absolutely 90 degrees. So the screw doesn't push the wood, because the wood will pull it. And if you've ever put a screw in wrong and tried to take it out and redo it, you'll find it is really hard to get it to go to another direction, because it wants to follow the hole. The more important it is, the better the chance of you doing that is. So the neat part about the hand drill, though, it gives us a lot of flexibility. Sometimes too much, so we need things to make sure it goes, in this case, 90 degrees. We can get attachments to do this. This is a 90-degree attachment. Now, I make a lot of Adirondack chairs, and in the course of making the Adirondack chair, you make the frame, then you put the wood on the back seat, and then the last pieces of wood you put on the seat. The problem is that arm's in the way. So when I go to drill a hole, I've got an arm in the way. I can't do that until the way I can get in this here at an angle, and I don't want screws in an angle. So this is what you use. Come in here at 90 degrees, push down, and you go, you drill. Take the drill out, put your square drive in there for your screws, same thing. No, I don't go as fast with those. You just put those right in, but that allows you to get into tight little places. And this is a great feature. How difficult is this to use? Pull it off. There we go. Pulls right off. Now, with the fest tool, you can put this, we call it a concentric chuck. You can put that in here like this. And if you've got anything that's got one of these bits in here, word of caution, fest tools from Germany. What do they measure in? Millimeters. So if you're getting one of these, you want to see the words Festool compatible on the label, because an American one won't fit into this, but a Festool one. Drill bits, they have drill bits with this on the end, or you have this concentric. If you just don't want to mess with that, you take it off. Same thing on both ends. One drill, the whole Festool system, all those accessories fit with this. So this one is a regular drill head we're used to. Don't want to use that. Use this chuck. Don't want to use that. If we don't want to use a screwdriver with that, we want to drill a hole, we can put this head in here. So options, we got a lot of options. Again, it's just how deep rabbit hole. This will actually let you do many, many things that you can't get with another type of drill. Now, there are adapters. We sell adapters here that go in any type of drill that will turn it 90 degrees. There's also stuff like this that goes over something, so when you put it down, you're drilling a hole tap dead center like a little mini drill press. These all are neat features that work. Sanding, I use mine for sanding a lot. Put this in here, turn the speed down, it makes a great sander. Disadvantages of these. The biggest disadvantage with these is that these are light work. Just little holes, not, These are great in the wood shop. Could I use these to drill holes in masonry? Oh, absolutely not. Why not? Because 3 seconds in, I would suck all the power out of the battery, because that's that much load. So there are some drills that if you're going to use really heavy, thick stuff, if you want to drill in metal, you want to drill in any type of ceramic or brick or something really dense, then you want one of these things that's got a plug dangling off of it. Okay? And normally those types of drills, you're going to sweat when you pick one up, and they've got 2 handles to hold because they're so dang heavy. But that's what you need. For all the stuff we use, this is fine. When you come use these, make sure you've got some extra batteries and some extra rechargers, because as you're using one, the other can recharge. But on the whole, these are both excellent. You just, oh yeah, this is. This one's a little bit more powerful. Yeah. Actually, should take this out when I do that because it hurts. Now, how this works is, this little thing that moves, you pull it out to take it off or put it on. This in or pull out to put the drill on, or the screw head. So this big one attaches to the motor. This little one attaches whatever you're putting in here. And it's got to be metric. So we talked about the different ways to drill holes. We talked about the bits that we use, and we're basically going to use two, brad points or Forstners. We're going to see these things, and we've got some of these that are this long, and they have a point. But if you've got something this long, never use it to start the hole. Always use a smaller one the same diameter to start the hole. So when you put this in there here instead of right here on the tip, because you saw the vibrations, you can get into this stuff. Okay, and this just make a cleaner cut and easier cut, and the machine won't work as hard, and you won't work as hard. It's important that you clear the bits. So if you're doing a deep dive, bring it out, take it in, bring it out, take it in, because if you don't get that stuff out, you're going to get friction in it, and it's going to burn, and it's going to burn. Why do we care? You'll never see it, right? It's because it'll stress the wood itself. It'll put cracks in the wood, because when it gets hot, what happens to the moisture? It goes really, really hot, and pretty soon it starts to generate steam. And the wood's going to react to steam by expanding, okay? And then you drill your hole, you take the drill bit out, you set the wood aside, and what's going to happen to the steam in the wood? It's going to leave. What's the wood going to do? Cool. What's the hole going to do? Shrink. So all of a sudden, I don't understand why this doesn't fit. It fit earlier. When you drill that hole to put that dowel in, and you come back and put the dowel, and the dowel won't even go down there without you hammering or put a lot of wax on it. That's why. It just means be a little bit more gentle drilling a hole. Clear the wood. Don't let it build up friction. If you are struggling to push the bit in, it's just not working. If you got a brad point, throw it away. Buy another brad point. It's dull. If you've got the spade bit, you can put it into something like the Drill Doctor and sharpen it again and keep on using it. But we don't normally use that type of bit in woodworking because it wanders a lot. We want that little brad to get in there and dig in to keep that drill head from moving. So if you're pushing and it ain't working, even if it's a Forstner bit, toss it. Yeah, you can sharpen that stuff. I can sell you $100 machines and even more to sharpen this stuff, or you can just throw it away, buy another $5 one, and off you go. Now, you're going to drill bits, a set. Some sets will be $50. Some sets will be $200. You don't see it so much in the brads as you do in the Forstners. You can look at it. We got one Forstner bit over here. On one package, it's $7.99. On another package, it's $49. What's the difference? Well, kind of, sort of, yeah. One is from China, one is from Germany. So I already got a clue about the engineering behind it. But the more expensive Forstners are designed to drill just as well into end grain as they do side grain. The cheap ones are just designed to go into side grain. They do not play well at all with end grain. You won't like it. It's actually going to be more expensive for you to buy that does end grain if you need to go in than it would be to cheap one. And if you're doing this for bottle stoppers or cigar holders, you're going in end grain. This was easy. This is a piece of cake. If you look at this one, look how, this was a cheaper bit. Look at the edges here and look at the edges here. And you'll see the big difference between a good end grain bit and one that's not so good. And that one is really not so good. It's quite a bit different. The good end grain bits, you can tell that both those holes will look exactly the same. So it just depends where you want to go. So usually it's not the setup, it's not the drill press or the lathe. Normally, if it's not working right, it's the bit. And when I say usually, 99% of the time it's the bit. Any questions about anything we cover? The biggest thing was letting you guys know what you have to work with, but what's available to you. I can't imagine a wood shop that didn't have a drill press. because I can set up repeat holes in this case. Boom, 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 and it's great. It does a good job. This one I couldn't make this without this arrangement, and this one particularly, those pin vices, and you'll see them up there, and it's on the wall, but they're really long, they're really thick, deep V's. There's only 2 of them, but because it's a deep V, it holds that blank. Now, what I do with my blanks before I actually do anything with them, I've got a jig on my table saw that I will take these blanks, and I always make sure they're a little bit bigger than 3/4, and I will cut this around, and this will be exactly tap dead center 3/4. Once this is exact, when I put it into those pen jaws, that holds exact. But until then, if this is bigger here and this is skinnier here, it's not going to line up quite right. So absent anything else, if you want the hole to be centered, you're going to use something like this, and you're also going to make sure this is, whatever you decide, it could be an inch square, it could be 3/4 of an inch, it could be a 1.5, whatever you decide, it's got to be that way, the whole blank, it's got to be. And you can set up simple jigs to do that. And I do that in my wood shop. 3/4 of an inch, I slap a blank in here, make one cut, flip it, make another cut. Now I got a 3/4. I'll go all the way around, but usually the last 2 don't touch anything. But if it's fat here, and I make a cut this way, and I flip it over, and I make a cut this way, it's still fat in one spot. So I always try to go all the way around, and sometimes you'll hit, most times you don't, but now you've got something that's dead exactly perfect. Then if I take it to here, I'm going right through the center. Make sense to y'all? That's basically it. Any questions about the tools, the blanks, what to do? And the 2 times, like I said, the 2 times I've hurt myself, and they were pretty good whacks, with this, with no clamping. It's me holding it. Because if that bit grabs that wood, and if you're turning at 800 RPMs,
It's going 800 RPM.
that's a good whack right there.